Okay, so today we're doing experiment number 5, which is chemicals in the home, and the primary objectives of this experiment are to recognize commonly found chemicals in the household, be able to write balanced chemical reactions, and also to predict the products of those chemical reactions. And with this experiment, you will use your experiments that we are going to go through and help you to determine the identity of an unknown compound. So one of the first things that you have to be able to do with this experiment is you have to be able to write a balanced chemical equation, and you have to be able to predict the correct products. Okay, so let's look at question number 1 in the pre-lab. We see that we are asked to write a balanced chemical equation between solid smelling salts and aqueous sodium hydroxide. So what this question has given us is the reactants. It hasn't given us any of the products essentially, but what you can see here is with this note, it actually does inadvertently tell us some of those, but we'll get to that in a minute. So we have solid smelling salts and we have aqueous sodium hydroxide reacting with each other. So we know the formula for sodium hydroxide. We have NaOH, and it tells us that it has the aqueous phase. And remember, when you're writing balanced chemical equations, you not only have to balance everything by mass, but you also have to include the correct phase. Okay, so we have sodium hydroxide in its aqueous phase, and it reacts with solid smelling salts. Now, in order to determine the chemical formula for the smelling salts, you have to look back into your pre-lab reading. And when you do, you'll find that ammonium carbonate is the compound used for smelling salts, and this is a solid. So you see here we have solid, we know what phase it's in, same thing with the sodium hydroxide. Now, this has given us our reactants, but we have to be able to predict what our products are going to be. Now, if you look, we see that both of these two compounds are ionic, meaning they have a cation and an anion. So I'll highlight the cations in each compound in yellow, and I'll highlight each of the anions in green. Okay. So we have an ionic compound, both ionic compounds, and we have cations and we have anions. Now, the easiest way to predict what your products are is to do what I call a crisscross method. So what do I mean by that? Well, we have cation number 1 and we have anion number 1. We have cation number 2 and we have anion number 2. And basically what I mean by the crisscross method is to switch. So what I mean is we would take cation number 1 and pair it with anion number 2, and we would take cation number 2 and pair it with anion number 1 in order to determine what our products are going to be. So let's do that. Let's take cation number 1, this is sodium, okay, and we take that, and since we are crossing it and connecting it with A2, we see that we have it connected with carbonate. Now, I wrote these two apart because you have to make sure that you balance the formula correctly. Now, you know in this compound here that sodium has a +1 charge. So we have a +1 charge for sodium. And you know by looking at this compound, carbonate, which is a polyatomic ion, has a 2- charge. So we have 2- here. Now, in order for this compound itself to be properly balanced, you can do an additional crisscross method. So what do I mean by that? I mean that we take only the number and we crisscross it to make it the subscript of our new compound. So this would be Na2, then we'd have carbonate, CO3, and this would be 1. Now, you know that when we only have 1 of anything, that the 1 is omitted. So this becomes Na2CO3. Now, if you look at this, you want to make sure, because you know that ionic compounds need to have an overall charge equal to 0. So this has a +1 charge, this has a -2 charge. So if we double check our answers to make sure that we properly balance this formula, we see that we have +1 for sodium, and there are 2 of them. We have a -2 for carbonate, and there is one of them, this better equal 0. And what we see is that in fact it does. So we know that this is one of our products. So we have here, we have Na2CO3. Now, the other thing that you have to identify is the phase of this compound. And in order to do this, you have to know your solubility rules. So if we look at our solubility rules, the ones that you've learned in class, typically we see that carbonates, compounds containing carbonates, are insoluble, except when they are paired with a group 1 metal, which sodium happens to be. So this would actually have an aqueous phase. Okay? So we've taken care of one of the compounds. Now we have to look at cation number 2 and anion number 1. And we do it in much the same fashion here. So if I erase real quick, we have cation number 2 is the ammonium. So we have NH4, and we know it has a +1 charge because this is also a polyatomic ion. And anion number 1 is, let's see here, hydroxide. And this too is a polyatomic ion, and it has a -1 charge. So these are the two that go together. We want to make sure we balance our formula, so we take our number and we crisscross, and these now become our new subscripts. So this goes on to be NH4, 1, and OH, 1. And again, when we have one of them, it's omitted and understood to be there. So this then becomes ammonium hydroxide. And again, we want to double check that the overall charge of this compound is equal to 0. So we know that we have one ammonium and it has a +1 charge. We have one hydroxide and it has a -1 charge, and we know that this overall has to be equal to 0. And if you do the calculation, you know that it indeed does. So now we know what our second product is. We have NH4OH. And again, we have to identify what our phase is. And if we look back at the solubility rules, we know that hydroxides are typically insoluble unless they're paired with a group 1 metal or ammonium. And since we have ammonium here, we know that this has to have an aqueous phase. But if we look at this compound, we see, oh, ammonium hydroxide does not exist in solution, but actually decomposes to gaseous ammonia and water. So we know that even though this should technically form, it decomposes, meaning it breaks down into gaseous ammonia. So we know what the formula for ammonia is, NH3, gas, and H2O, liquid. So although typically we use this to determine what the product is, sometimes they have a further reaction and decompose. So now that we have our products formed, we now need to do the final step of our chemical equation, which would be to balance it. So we have to balance this by mass, and if you go through and balance everything, what you'll see is that you have 2 sodiums on each side, or on this side, so most likely you are going to need a 2 in front of the sodium hydroxide. Now again, remember, with balancing chemical equations, it's by trial and error. There's no, simple set of rules that say do this, this, and this in order for you to balance it quickly. You simply have to play with it in order to get all of your elements balanced on each side. But we see we had 2 sodiums on the left-hand side, we have 2 sodiums on the right-hand side. If we look, we see that we have a difference in our ammonia and also with our H2O. So with this one, we know on the left-hand side we have 2 nitrogens, so we could put 2 nitrogens here and then check from there. We see, okay, how many oxygens do we have? We have 2 oxygens from the sodium hydroxide, we've got 3 from the carbonate, so that gives us a total of 5 on the left-hand side. Over here we have 3 from the carbonate and only 1 here, so that's 4. So chances are we're going to need another 2 here. So if we go through, we know we have sodium balanced, we have the nitrogen balanced. If we look very quickly, we see carbons also balanced. We have the oxygens balanced. The last thing we have to check is the hydrogens. So if we look at sodium hydroxide, there's 2 hydrogens. From the ammonium, we have 8, so a grand total of 10 hydrogens on the reactant side. We have to make sure that we have 10 on the product side. And what we see is that we have 6 from the ammonium and 4 more from the water, which gives us 10. So therefore, we know that everything is balanced by mass, and this is our balanced chemical equation. Now, in terms of products for this problem, okay, we now know what they are. We have the sodium carbonate, aqueous, we have the gaseous ammonia, and we also have the liquid water. So we already know by balancing the equation what the products are. So we have, and would write, sodium carbonate, we have gaseous ammonia, and we have liquid water. Now, in terms of experimental observations, okay, if you look at your products, what you can see is that you're forming ammonia in the gaseous phase. And this is going to be a telltale sign of the fact that you have this compound present, because you will be able to smell the ammonia. So this is the experimental observation that you should expect to see with this particular reaction.